Welcome back to the DevSecOps experience. Today I want to tackle another really important topic for DevSecOps engineers, especially in the last few years, securing Kubernetes. Today I'll focus first on networking. I'll have some additional videos on other aspects of Kubernetes like RBAC and things like that. But today I want to deep dive into Kubernetes networking. Alright, so let's get started. First, a quick primer. What is Kubernetes? So why are we even using Kubernetes today? Why is it a popular tool? The reason is it's a really popular abstraction layer or virtualization layer to interact with many servers in the cloud. So if you as an organization have a ton of applications and you want to deploy them, well, you want to deploy them in a really efficient way, and you don't really want to care that much about what IPs each server has and each team, each application having super customized deploy processes. You want to be able to have sort of a one-size-fits-all mentality, even though the cloud is full of different servers, IPs, etc. And Kubernetes makes that possible. It's built on one main piece of technology, which is containerization. So long as you're able to package your application into a container, into a Docker container, a Docker image, which we can have a separate conversation about that, but if you're not aware, if you can package into a Docker image, then it can be deployed onto a Kubernetes cluster in a really simple way. And you can, as the DevOps of your organization, can build really nice what's called golden path that all of the developer teams can follow to deploy their applications onto a Kubernetes cluster. And Kubernetes, the nice thing it does is it takes away the responsibility of the network manager and things like that, having to manage each individual node by hand and figuring out where to place things, because Kubernetes will be smart and sophisticated. No, here are the nodes, the servers I have available to me, and I'll do the scheduling. I'll figure out which ones are healthy, and if not healthy, I'll restart them for you. And it takes all of the initiatives that make it the best possible chance that the applications will be healthy and running. And even better than that, if it uploads a new version of an application, if you deploy a new version of your application, but your new version isn't passing its health tests, then Kubernetes won't take down the old version. And so it's really cloud native that sort of says, let's assume that things will break, and let's build things based on that assumption that things will break, so that we do the best possible job that will still be running, even when we push bugs to production. That's the idea behind Kubernetes, to really make the production environment and your applications as resilient as possible. And so that's the reasoning behind it. Not all secure. It's not a security-based motivation. It's more for DevOps and for streamlining deployments. So now that we have a little bit of background in there, as you can see, the main thing I want to cover here from a security perspective, first and foremost, is there's this idea of the control plane. And then here, the nodes, that's the application plane. The control plane in a cloud-native environment, this is being managed by the cloud provider. And the nodes are being managed by us, the customer of the cloud provider. And what that means is segmentation of responsibility. So when it comes to security, the cloud provider is responsible for securing the control plane, and we're responsible for securing the nodes. That being said, we do have a little bit of responsibility on the control plane as well, because when we provision the cluster and when we manage the cluster, we could provide certain configuration properties to the cloud provider, tell them what things we want them to know about our control plane. Okay, so first I want to focus on external networking. What I mean by external networking, I mean how can traffic get to your cluster? Because obviously you do want applications to communicate with your cluster. You do want customers, if you have a public-facing application, website, whatever it is, you do want obviously traffic, the healthy traffic, to make it to your cluster. At the same time, you want to keep away bad traffic. So I want to focus on how do you secure the networking of your cluster. So first and foremost, when you have clusters in any cloud native environment, there is the private endpoint and public endpoint option for your control plane. What does that mean? When you provision a cluster, Well, it has to have an API, and you can see that here. There's an API. Well, that API, you're using it all the time, and you might not even realize if you're using the Kubernetes CLI. Well, it's using it's using the Kubernetes API. So if you want to say, hey, show me my pods, or if you just want to authenticate and say, I want to authenticate with my cluster, all of those things are being done against the API, which is hosted and managed by the cloud provider. But when you provision the cluster, you get to decide, hey, should that be a public endpoint or a private endpoint? Because it's an API, it needs a DNS record. And you're deciding whether that DNS record should be a public DNS or private DNS. Obviously, for security purposes, we want that to be a private DNS. Because if it's a public DNS, that means that your cluster's API endpoint is public facing, and anybody in the world can talk with it. And if there happens to be any sort of 0-day vulnerability, or you just didn't configure your IAM and access policies, they might be able to anonymously do things onto your cluster now. So it's really important to use private endpoint. And you can configure this when provisioning your cluster. And it's not too late. Even if you already provision your cluster, you can oftentimes change it. And most clouds, they'll let you change it in the middle, although you do need to be careful about the effects of that. It's definitely a maintenance window. You need to communicate with your developers. But you want to make sure all of your clusters are using private endpoints. And when you use private endpoints, you can control what networks are able to talk with it. So that'll be accessible to your private network. And then you'll want to also enable that to your, let's say, your VPN. So that way, you as security engineers or the DevOps developers can still have a way to communicate with the cluster through that private endpoint. Next, I want to talk about ingress networking rules. So another important aspect of your Kubernetes configuration is you're provisioning what are called a node group or a node pool, which is all these servers. And because they're at the end of the day still cloud servers, they need to have networking rules, which means what ingress, what network traffic you're allowing into it, as well as egress, which is a little bit separate from this and for this purpose, but obviously similar. It'll be defined in the same place. Now, if you're using public nodes, which I'll talk about here, this is critically important. But even if not, you still want to make sure that you're limiting the ingress to only the relevant sources of traffic and only to the relevant ports. That means if you're running these different nodes or these different node groups, you want to limit ingress to only the IPs that you care about, and this would be an IP range. So the IP range of your VPC, your virtual private cloud, or your IP range of a number of VPCs if you have VPC communication across multiple accounts, etc. if you have a pretty large environment, and then also to your VPN similarly, potentially for debugging purposes, things like that. And then also port base. You don't want to open up ports you don't need to. And so you want to limit the networking just to what you need to. It's sort of like least privilege access, well, least privilege networking. It's really important to do this to really limit only what's necessary, and you eliminate a lot of potential attacks just by having a more secure networking of what could actually reach your cluster. Even if you're using private subnets, which I'll talk about now, you still want to do this because you don't know whatever can get you don't know what's compromised, and it's hard to have certainty in the world of cloud security. You just want to have the best practices enabled as much as possible so that even if there is a compromise, the impact is limited. And so these are important steps to take. This is critical to take. This is like first basic step. You need to have private endpoints. But this is also very important. I would say second most important is private subnets where possible. So why private subnets? If you deploy your application plane nodes on public subnets, that means every one of the servers that's underlying your Kubernetes cluster has a public IP. And if it has a public IP, then it's to a degree reachable by the public world, and it's reachable by attackers. And you really don't need public subnets. Why? Because you want your traffic to come to your cluster through centralized places that you manage elsewhere. That could be application load balancers, that could be network load balancers, but those live outside of the cluster on the private network, with public IPs, and there you secure them in a centralized place, and you keep your actual compute running on your Kubernetes cluster really secured and private. That way, the only things that are allowed to come to communicate with your cluster are through these sort of allow listed, hey, I know what's supposed to talk with my cluster. It's this load balancers that I own, and I know what configurations I have on them. Whereas if you make them on public subnets, now every one of those nodes has a public IP, and now you need to worry a little bit. Well, who's sniffing my network? Who's guessing my IPs? Who's trying to take advantage of the fact that they're public, different vulnerabilities? Now you have to be really paranoid about what vulnerabilities are being disclosed today about Kubernetes nodes. So this first and third are critically important for that reason. And then the ingress networking rule will really take it a step further to limit it further. Okay, now I want to talk a little bit about internal networking. So this is, you have a Kubernetes cluster, and not only for your Kubernetes cluster, but just generally your virtual private cloud or your private network, how to design it. If you're not careful, if you take sort of the lazy route, then everything goes on the same large subnets. So you have your VPC, you create a few big subnets, and then you say, hey, I want my whole cluster to run on these subnets. I don't really care which applications, I don't care any granularity, I just want everything to run on these subnets. And then you might use those same subnets now for your load balancers. You might use those same subnets for your databases. And now you've gotten to a place where your all of your critical things that should be really segmented are all living now on the same subnet, which means they can communicate really easily one with the other. If one gets compromised, well, pretty much they got the whole basket. And so there's this concept of purpose-driven network segmentation. We want to do this in our VPC, and if possible, we want to do this on our Kubernetes cluster as well. This means creating different subnets or different IP spaces for different groups of applications by their purpose. So on the VPC level, this could be, I could have one for private network ALBs, meaning private load balancers. I could have one for public load balancers. I could have one for my databases. And I could also have one for my actual compute, my application layer, which is all my custom applications that I'm writing, or that the developers are writing. And if you're running a lot of these things on the cluster themselves, then it's even more important to have this on the cluster. So you could have subnets dedicated to networking applications on your Kubernetes cluster. If you're self-hosting databases, you want to have subnets dedicated for those, and then subnets dedicated for your actual application layer. And then if you want, you could even go further and more granular and have subnets dedicated to different types of applications. Let's say your organization has two very distinct teams, but they're running on the same environment. Well, their applications never need to communicate one with the other. Well, you could create different subnets for those purposes as well. Obviously, you want to be careful and really have a well thought out design for your segmentation, because it's not a fun migration to move all the time, but it's very doable. And what's nice in the Kubernetes world, there's this concept of node selector. So what happens is you create different subnets. On those subnets, you create different node groups. And then in those node groups, you can give them identifiers or properties that make them identifiable. And then in the Kubernetes native world, when you create Kubernetes deployments, you can use different Kubernetes properties to actually say, hey, I want my application to run on a node group that has this label. Or the opposite, you could say, my Kubernetes application is not allowed to run on nodes that have this label, etc. And you have a lot of granularity. There's things called affinity rules, node selector rules that you can use on your deployments, and Kubernetes resources to really control where they get deployed. And also, if you need to migrate, you could change it, and then the pods of that application will start to migrate to the new subnet. So this is a really powerful tool to then enable more strict networking, so that if one part of your network is compromised, you don't lose your whole network. Okay, next I want to talk about pod-to-pod communication. This is an important detail. that maybe not all of you are aware of. By default, when pods on a Kubernetes cluster communicate with each other, they're using HTTP protocol, not HTTPS, meaning it's not secured. There's no certificate authentication between the two pods, and that's a risk, especially if they're not on the same node, because that means traffic across the private network, maybe even the public network, depending on how the cluster is deployed, is effectively unsecured, meaning if there's a man-in-the-middle attack, they could sniff it out. So it's really important here to use what's called a service mesh, which enables you to add a little piece of technology next to all of your applications running on the cluster, so that when they go and make a request, an HTTP request to another pod, they're proxying through it, and that what's called a sidecar, because it's deployed on the side, will ensure that the traffic that actually goes out is now secured, and you can control the certificate policy there. That's the classic way that service mesh technology works. Here's the three most popular: Istio, Linkerd, and Consul. But I do have to warn you, service meshes can, if you use them for all of their features, they're very cool, but they're also a heavy burden. They can take on a lot of complexity, and you really have to be careful about the design. If you're going to use a service mesh with sidecars, you need to really talk with your DevOps and come together for a design that enables really good security, but also scalability and ease of management. Another option here, I didn't write this, but it's really important to know, is there's a new emerging technology today in the service mesh world. You could see it from Istio. It's called ambient service mesh. Why is it ambient? Ambient meaning quiet, because unlike sidecar-based service meshes, which are essentially, you could think of them as noisy because they're being deployed everywhere. You're putting these sidecars on every single pod. The ambient service mesh is being deployed on the node level itself. So you could have a single server or node that has many applications. Now, instead of a sidecar in each one, you're actually just telling the node itself, hey, when you talk with pods on other nodes, please use secured communication. And you're enabling that MTLS traffic, mutual TLS, between pod to pod on different nodes without having to actually modify each pod itself. And this is really powerful because it really makes it easier to manage. It's not accidental they called it ambient, because you don't really need to now worry about, oh, what this sidecar, if you have other sidecars, how are they interacting with each other, and all the complexity of deploying a technology that's being appended on every single compute. Whereas here, you're just sort of making a small modification to the networking of the underlying node so that it ensures it's always using that HTTPS traffic. And you could look into a Istio ambient service mesh. It's very cool. Recommend it. Okay. Lastly, there's also Kubernetes native networking. Now here we're talking about Kubernetes resources and different things you could actually do application native on Kubernetes that also add more levels and layers of network controls. So for example, if you want to limit which namespaces can communicate with other namespaces, or which applications or deployments can communicate with other deployments, there are tools that can do that. The Kube native tool is called network policies, but there's all sorts of other popular tools. The ones I mentioned here above, Istio, Linkerd, Consul, also enable it as service meshes. They enable all sorts of abstractions on top of the service mesh to say which things can talk with which other things. But then these are also other popular tools, Calico to restrict ingress and egress, which IPs are allowed into the cluster, which IPs are allowed out of the cluster for different applications. WeaveNet and KubeRouter are also popular in the last few years that enable all sorts of really granular controls over networking on different actual Kubernetes resources. So this is also a really powerful tool that's a little bit more advanced. These were the main points. So like I said, you should use private endpoints for the cluster control plane. You should deploy all their node groups and private subnets as much as possible. You should limit the ingress to the cluster only to what's absolutely necessary, both IP-based and port-based. You should use purpose-driven subnet segmentation. And you should secure pod-to-pod communication. And then Kubernetes native network controls are a really important feature to also bring on for that last layer and really full control. That's it for this video. The next video I'll focus on will be more on access control and access management. in Kubernetes. See you next time.